Well, welcome. In the previous video, we were introduced to the idea of inverse variation functions in the form y equals k divided by x, and we called those hyperbolas. Well, in this video, we're going to be looking at equations in the form y equals k divided by x squared, or it could also be written as k times x to the negative second power. And when you see something in this form, they're called the inverse square curves or inverse square relations. So when we look at these graphs in a little bit, you'll see that there's a slight difference between what we looked at yesterday or in the previous video with hyperbolas and with this video with inverse square curves. Now in the previous video, we were also introduced to this four-step process to be able to work out a story problem. And where the first step is to write a general equation. Now that general equation for this set of problems we'll be looking at would be typically in the form y equals k divided by x squared. And once you know that general equation, the second step is to figure out, well, what's that value for k? To find out what that value for k is, what you're going to do is they're going to give you a specific scenario in the equation where they give you the values for the variables, the y and the x or whatever the variables are going to be. And you plug those numbers in for those variables, and then you just solve your equation to figure out what k would be. And once you know what k is, well, now you can move on to the next step, the third step, and write a specific equation. So we go back to your answer from step one, your general equation, take the value that you have for k in your second equation, merge those two together, and you have yourself your specific equation. And once you have your specific equation, then you can go on to the last step, which is to answer the question you're trying to find. So if you can follow those four steps, you want to make sure that your work is organized. One of the common mistakes that I see people make is they forget to carry the exponent through. So if your equation starts with an exponent, make sure that when you're doing your work, that your very last step also includes an exponent. So let's look at a couple of examples now where we're going to be able to use these four-step process.
So here it says the force exerted by the electrical field between two charged objects is inversely proportional to the square of the distance between them. Let's stop there. So in the first sentence here, it's going to give us the general equation. So if we're working on it, obviously in this section, it's going to be k divided by x squared, but sometimes our story problems will be intermingled with the stuff that we talked about in the previous video. So it's important to always look for that phrase, inversely proportional. Because if you see that phrase, inversely proportional, we talked about this before, that it's equal to k divided by. That's what that phrase represents. So before that phrase, you'll get your first variable. So here it's talking about the force exerted by an electrical field between two charged objects. So I'll just use F equals k divided by something. And then after that phrase, inversely proportional, is what we're going to be dividing by. It's going to be the square of the distance between them. So there's your equation. That's our general equation that we would use now. So that is step one. Step two, we want to figure out, well, what's our value for k? To figure out our value for k, we're going to have to look for a specific scenario. It says at a distance of 1.5 meters, you measure a force of 30 newtons. So there's your specific scenario. We know that from a distance of 1.5 meters, our force is going to be 30. So I'm going to put those values in, make sure you put them in the right spots. And so then we would have your 1.5 being squared in our denominator. Now, to find out what k is, we want to get the k by itself. Now, what we're going to do is we're going to multiply both sides by 1.5 squared. I mean, if you wanted to, you could simplify 1.5 squared and multiply both sides by that value, but it's just going to be a big, ugly decimal. So let's just do multiply both sides by 1.5 squared on your calculators, and you get your value for k then, which is 67.5. So now we're ready to move on to step two. Step two is where we're going to be writing a specific equation. So I'm going to take my answer from step one, that f equals k divided by d squared. I'm going to take just the k that I got in step two. I don't need the 30 and the 1.5 anymore. I am done with those two numbers. So my equation is just f equals 67.5 divided by d squared. And now I can use that equation to answer the questions. It says, what will be the force at a distance of 3 meters? So I'm just going to put 3 in here for D. And when you do that on your calculator, if you take 67.5 divided by 3 squared, we get 7.5 newtons. Now, if they ask us what about at 15 meters? So we're going to do the same thing, 67.5, this time divided by 15 squared, and we end up getting 0.3 newtons. Which illustrates an important point about inverse variation, which is as your independent variable increases, your dependent variable is going to decrease. So when we go from 3 meters to 15 meters, our force should be decreasing. And sure enough, it does. It goes from 7.5 newtons to 0.3 newtons. Well, why don't I have you guys try this next one on your own. You're going to follow those same 4-step processes for this story problem, where it says the intensity of light from a point source is inversely proportional to the square of the distance from the light source. Suppose that at a distance, the light intensity is rated at 600 lux. What will the intensity be at the distance of 10 centimeters and then at 23 centimeters? So why don't you guys take a minute and work this one out on your own. So pause the video and hit play when you're ready to check to see if you have the correct answer. Okay, you should have gotten these two numbers as your answer, 150 and 28.36, but let's talk about how you would have gotten that. So again, we start out with I equals k divided by d squared. Then they tell us that it's the light intensity is 600 lux when the distance is 5 centimeters, so put those numbers in the appropriate places. And when you multiply both sides by 5 squared, you get 15,000 for your value for k. So your specific equation would be I equals 15,000 divided by d squared. Then you plug in the distance of 10 centimeters, put that in for d, and you end up getting 150, so it'd be 150 lux. And then you put 23 in for d, and you end up getting 28.36 lux. So again, this illustrates that as the distance from the light source increased, the intensity of the light decreased. Well, let's take a second now and look at our graphs for an inverse square curve. And let's look at our graphs for a hyperbola, and we can compare and contrast these. So here we have our equations on the left. These are for our inverse square curve. Now, some important things to note here is that our domain and range for this is going to be this. I'm just going to be looking at the first one here for when k is positive. So when k is positive, it's in quadrants 1 and 2. When k is negative, anytime you have a negative value for k, it causes the graph to flip. So it would be in quadrants 3 and 4. So the domain here would end up being all real numbers except x couldn't be equal to 0. Because if you look at your equation, remember a lot of times it's easier just to look at the equation to figure out what our domain is going to be. Because if I didn't have the graph, if I just had the equation like y equals 17 divided by x squared, the one number you can never divide by is you can never divide by 0. So your domain would be all real numbers except 0. Now, to find the range, we can look at the graph for that, and you can see that it goes from 0 and then it goes up to infinity. But if you notice, the line gets really close to where y is 0, but it's never going to actually touch it. So here you could say it's a set of all y's such that y is greater than 0 would be your range. And the reason for that is because if you think about it, if I had the equation 17 divided by x squared, not only could I not divide by 0, but I can never get 0 as my answer. So it doesn't matter, because since you can't put 0 in there, we wouldn't get 0. And plus, it doesn't matter how large of a number we put in. If I put in 1 billion, I'd end up getting a decimal with a lot of zeros, but it would never be exactly equal to 0. So my range is where y would be greater than 0. Now remember, we've talked about asymptotes before. And this also has two asymptotes. The asymptotes are x equals 0 and y equals 0. X equals 0 is a vertical line going through where x is 0. So if you notice, both graphs get really close to that line, but it's not going to actually touch it. For the same reason that we can't have an equation with, or we can't divide by 0 is why we have x equals 0 as an asymptote. Remember, an asymptote is an equation x equals 0, it's not just 0, it's not just x, it's got to be x equals 0. Same thing with our horizontal asymptote would be y equals 0. Y equals 0 is a horizontal line going through the point where y is 0. On both lines, get really close to that line without ever actually touching it. And recall the asymptotes for the hyperbolas that we talked about in the previous video had the same asymptotes, x equals 0 and y equals 0. Now those are just some similarities between the two. Remember the domain and range that we talked about in the previous video. The domain for a hyperbola is going to be all real numbers except x, or except 0, because again you can't divide by 0. So the domain is the same between these two sets. Your range, however, for this is going to be all real numbers except for y can't be equal to 0. So if you look at your graph, the line gets really close to the y-axis, but it doesn't actually touch it. Because for the same reason as the previous video, you can never take a number and divide. Like if I had 17 divided by x, I can never take 17 divided by a number and get 0 as my answer. But it has the same asymptotes as the previous version, so that's going to be the same. Also notice that when k is negative, it causes your graph to flip from being in quadrants 1 and 3 to being in quadrants 2 and 4. So that's the impact that k has when k is negative. So that summarizes the graphs for these two types of equations, and now you should be able to complete your assignment. So with that, good luck.